Hi guys, I'm Cora Thomson and today I'm going to be making a video on acetylsalicylic acid, or as many of you know it as aspirin, specifically on its structure and properties that are important in its role. First of all, let me explain why aspirin is significant to my life. When I'm not at uni, I spend most of my time in a chemist. As a pharmacy assistant, I sell a wide variety of medications, from over-the-counter medication to dangerous drugs that require a script. One of the most common medications I sell many times a day is aspirin. A lot of people think that aspirin is just a quick fix to treat your hangover after a night out, but in fact it's actually used for many different things and comes in many different forms. 100 milligrams of aspirin is used once a day to help thin the blood in patients who are at risk of myocardial infarction, or otherwise known as a heart attack, strokes, or blood clots. This comes in a straight aspirin form with an enteric coating covering the tablet to stop the aspirin from damaging the stomach lining and stop the development of stomach ulcers in the stomach. Aspirin in high doses is effective in reducing fever, inflammation, and swelling, and it comes in a variety of forms, such as chewable, dissolvable, and swallowable tablet. The chemical formula for aspirin is 9 carbons, 8 hydrogens, and 4 oxygens, and it's arranged according to this 3D structure. The red atoms represent carbon and the green atoms represent hydrogen. The blue represent oxygen. One of the first things you notice about aspirin is that it contains a ring of 6 stable carbon atoms, 3 containing double bonds and 4 carbons connecting to a hydrogen molecule. The 2 carbon molecules without hydrogen bonds here. The first connects to another carbon atom. This carbon atom forms a double bond with another oxygen molecule and then forms a single bond with a diatomic ion hydroxide, which is made up of hydrogen and oxygen together. On the other side, the carbon atom bonds with an oxygen atom, which bonds again to a carbon atom. This carbon atom has another double bond with oxygen and then also bonds with the methylene, which is made up of a carbon molecule and 3 hydrogen molecules. Each bond in an aspirin molecule is covalent. Aspirin's physical state is a crystalline white powder. It also can only be separated by chemical means, meaning that aspirin is a pure compound. One 320 milligram tablet contains 1.07 times 10 to the 21 molecules of aspirin. Aspirin can become a liquid with its decomposition at its melting point of 136 degrees Celsius, and its boiling point is 140 degrees Celsius. Another important property of aspirin is its binding energy. Aspirin's binding energy is 7,650.4 kilojoules. This means that hydrogen and oxygen atoms can move closer together because of weak intermolecular forces between the 2 atoms. This is called a weak hydrogen bond. The effect is what makes aspirin easy to dissolve in water. So here I have one 500 milligram tablet of aspirin, and it will dissolve in water quickly. So just like that. And this means that aspirin is a polar molecule and its solubility in water is 1 gram per 100 ml at about 37 degrees Celsius. So that took about 10 seconds to dissolve. So hopefully now you can see that there is a lot more to aspirin than a simple headache cure, and why it is a major molecule in my life. Thank you.